Okay, so today we're going to focus in on solving multiplication and division equations. So that's our objective, is to understand and solve one-step equations. One-step equations involving multiplication and division. Okay. In addition, you're going to also understand how to check your work. So just as a review, we had talked about on last week how we can solve equations using adding or subtracting. And so they fall under the property of addition, property of equality. So I want to review that for just a second. So addition tells you the operation. Equality means there has to be an equal sign, and we're going to treat our equation equally on both sides. So the addition property of equality says adding the same value to both sides of an equation So adding the same value to both sides of an equation keeps the equation balanced. And by balanced, it means that you haven't changed the meaning of one side or the other. Ryan asked, you're supposed to be taking notes. Okay, so balanced means that both sides, regardless of me doing the math, still have the same value because I've added equally the same amount to them. If you've ever used a scale and you've added to one side, you're going to tip it down on one side and it lifts up on the other. But if you add the same amount to the side that's higher, they balance out. So that means that you haven't changed value when you do math to both sides. Okay. So this one says for all rational numbers, and we're going to give you an algebraic version of it, A, B, and C. If I have, to begin with, if A equals B, then if I add the same amount C to both sides, I still have an equals between those. I haven't changed the values between those at all. Now, sometimes on the homework from Thursday and also on Friday, you guys did some subtraction. But that could still fall under the addition property of equality because we can add opposites is the same as subtracting. So that's why they're just going to talk about what you did for the last 2 days as just addition property of equality. Just like today, we're going to talk about another property. We're going to talk solely about the multiplication property of equality. Jacob.
So we'll just kind of go with like, say like you had a ratio of like 1 to 1, and you added 1 to both sides, it would still be 2 to 2, which would be like the same exact thing. Kind of.
Similar, because with a ratio, if you have a 1-to-1 ratio, that means you are you're actually dividing those two numbers.
Yeah.
But if you add 1 in the numerator and you add 1 into the denominator, then you've created 2, which simplifies down to 1 to 1. So it goes back to what it was to begin with. So the multiplication property of equality
That's the formula.
now, instead of adding to both sides, we're now multiplying. So it says multiplying both sides of an equation. Jacob, you're supposed to be taking notes. By the same value keeps the equation balanced. In other words, you haven't changed the value of the equation, it's still the same value. Keeps the equation balanced. So again, we have rational numbers, and remember rational is all the kinds. We've got fractions, decimals, positives, negatives, okay? A, B, and C. And then if we have this condition where A equals B, then multiplying both sides by C is not going to change the value of your equations. Okay? Now you might have think, well, why do we just talk about multiplication? Why don't we talk about division? But remember, if I have this problem, 6 divided by 2, I can use multiplication to solve that problem, right? I can multiply by the reciprocal. So that's why they can just say multiplication and division can fall under the multiplication property of equality, because I can rewrite any division as multiplying by the reciprocal. Okay, so division, we multiply. So the division becomes multiplication, and we multiply by the reciprocal. And remember, that's just flipping the number. Thank you. Okay, so on last week when we were solving adding and subtracting problems, we did the inverse operations. We're going to do the same thing here. So to solve equations, use inverse operations. So for us, these are just one-step equations. That means you're only going to see one operation. So if you have multiplication, what would you use? That would be the inverse of multiplying. Dividing. You can also use this notion above that you could also multiply by the reciprocal. And then if you start with division, the opposite would be to multiply. Okay, so real basic stuff. So what we're going to do is go through some examples, and then we're going to do checks. And then I'm going to give you a special case scenario that's really important that you understand this. And I'll give you a couple options how to deal with it. Okay. Okay, so the directions are going to say solve and check. Show all work. So just to remind you that if you ask me, do I need to show the check? The answer is, do you want to get it right? And this is your way to make sure that before you get the test back after I've graded it, you already know if it's right or wrong. If it's wrong, then you fix it to make it right. So that when I grade it, they're all right. This is the easiest chapter you could get 100% on. Super easy, provided you show your work. So, first problem. We're going to have real simple problems tonight. We're going to start getting complicated. I think we're doing word problems tomorrow. Let's see. And then multi-step equations starting on Thursday. And then more multi-step questions on Monday. And then we'll probably just take the quiz, do a little review on Wednesday, and then Thursday we'll take the quiz. All right, so what math is going on with the x? That's what we identify. We have multiplication. So the inverse of multiplication is division. So here's how I show division. And this is the best way to do it. I would not ever recommend that you show the old-fashioned division symbol. The high school will look at you and think there's something wrong. Okay? You're beyond that at this point. So we use the modern division symbol, which is the fraction bar. So that's 5x divided by 5 and 25 divided by 5. So we get x equals 5. Okay? So then we do our check. And the check says substitute in that 5 we got for the answer back in for the x and solve. And check to see if what's on the left equals what's on the right. And we get 25 equals 25. So what that says is, yep, x has to equal 5. Okay, so we've just verified the correct answer. Sophia?
Do we have to put the parentheses around it?
Well, I could use a division or a multiplication symbol too
Oh.
on the check. Yeah, that's fine. Okay. Ryan, you have a question? Okay. Isabel?
What is our test? Do we have a test this week?
No. Number 2. Negative t over 4 equals 6. Negative t over 4 equals 6. So remember my goal is to get t alone. So what math is currently happening to the t? And? There's 2 things, right? What am I dividing by? I'm dividing by 4. What am I multiplying by?
6.
No.
No, 4.
What am I multiplying by? What am I multiplying t by?
4.
No.
Oh, negative.
A negative 1. If you don't see the number after the negative, it's a 1. So t is not only being divided by 4, it's also being multiplied by negative 1. So guess what? I can take care of them both at the same time. What would I do to get t completely alone? That means get rid of the 4 from the denominator and get rid of that multiplication symbol. What am I going to do? Multiply by?
4. Oh.
Multiply, Connor, say it again.
Negative.
If I multiply by negative 1, that's just going to get rid of the negative.
4.
If I multiply by negative 4, now I'm going to get rid of the denominator, and I'm going to get rid of the negative. Now notice where I'm showing the multiplication. I'm showing it up in the numerator because I'm trying to get rid of the denominator. Okay, super important. If you guys show it close to the denominator, I'm going to take off points because that doesn't make sense. So a negative times a negative is a positive. And then 4 divided by 4 is 1. So I just get t on this side. On the other side, a positive times a negative gives me what kind of sign?
Negative.
Negative. And 6 times 4 is 24. So then I go ahead and do a check. Because especially when it comes to having signs, it's really easy to make ridiculously silly mistakes. So we're going to see, does the negative of negative 24 divided by 4, does that actually equal 6? Well, a negative times a negative is a positive. And 24 divided by 4 is 6. So I get 6 equals 6, which verifies my answer was supposed to be t equals negative 24. So let me show you how to solve this problem in 2 steps. Because for some of you, you might not like the 1 step. So first thing you could do is multiply by the 4 to get rid of the denominator. And that gives you negative t equals positive 24. And then you can either multiply or divide both sides by that negative 1. I'm going to divide by negative 1. Notice that I'm not dividing by a sign, I'm dividing by a value. So that gives me t equals negative 24. So you can do it in 2 steps, or you can do it in 1 step. Okay, you kind of have to think about how you want to do it. All right, so the next question I'm going to throw in a decimal and just kind of go through some reminders of how do you divide with decimals. So we've got 2.7y equals 54. So what math is going on between the 2.7 and the y? Multiplication. So the inverse of that would be division. So I'm going to divide by that 2.7. So off to the side, I rewrite this. 54 goes under the division house. It's the number that's being divided. 2.7 is the divisor. He's the one doing the division. What's the problem the way that I have it written? Justin? Yeah, we cannot have a divisor with a decimal. So we're going to multiply it by whatever power of 10 it takes to move the decimal point over to the right. So we would technically be multiplying this by 10, and that would move the decimal point over one spot to make it 27. But if I do that there, I got to do it to the guy inside to treat them fairly. So if I multiply him by 10, I have to add a 0. So my new problem is 27 dividing into 540. Okay? So how many times does 27 go into 54? Goes in twice. And I line it up under the 4 of 54 because that's as far as I'm dividing into. It gives me exactly 54. But I have a leftover 0. How many times does 27 go into 0?
0.
0 times. So what I get for an answer is y equals positive 20. Okay? Now I'm looking for all these steps. If you didn't have a decimal in your divisor, but there was one in your dividend, that's the guy under the division symbol, you would bring it straight up and then continue normally. Keep adding zeros if you needed to until you were done with the division. All right, so now we're going to do our check. And is 2.7 times 20 equal to 54? So off to the side, I have 27 times 20. I just temporarily drop off the division symbols, or the decimal points, I'm sorry. And then I go back, and there was a total of 1 digit after a decimal point, so my answer also gets 1 digit after the decimal point. And I get 54.0 equals 54. Is that the same thing? Yeah, because if I've got nothing after the 54, then it means the same thing. So that's verification that that is correct. So do watch out. You will have to divide with decimals. All right. Next one. Let's deal with fractions for a moment. Okay. So let me show you what kids do that is right along line with everything we've been talking about, but then ends up posing a problem. Okay. What math is going on between the 2/3 and the y? Well, you could technically say it's y is being divided or multiplied by 2/3. So the opposite of multiplying would be dividing. But that brings up this problem where now I have a fraction and a fraction. Just put that on my chair. Thank you. That's where we get a problem. So I'm going to show you an alternative way to doing this. Actually, I'm going to give you 2 alternatives. Alternative 1. Instead of dividing by the 2/3, what could I multiply 2/3 by to make the value 1? No, that wouldn't make it 1. That would make it 8/3. Okay, if I multiply by negative 2/3, I get negative 4/9. So that won't work. Okay. What do I multiply a number by in order to get 1? So this is your question. What do I multiply a number by to get 1? Because that's what I want. I want the coefficient of y to equal 1. Connor?
1.
No. 2/3 times 1. No. 2/3 times 1 is 2/3. So, Sophia got it. Okay. Well, you're so quiet, I can't hear you. Okay. Okay. What is 3/2 called compared to 2/3? He's called the reciprocal. So what we could do is if we have a coefficient that's a fraction, we can multiply both sides by its reciprocal. So we're going to write that down because that's kind of a handy piece. If the coefficient, remember coefficient is just the number that is in front of a variable and there's their product together. If the coefficient is a fraction, multiply both sides by its reciprocal. So for us, we're going to multiply both sides by 3/2. Now, what might make the right side a little easier to understand is let's turn 4 into a fraction. How do I turn 4 into a fraction? What does it get for denominator? Yeah, we just give it a denominator of 1, and now I have a fraction times a fraction, which may make this math a little easier. So the 3's cancel, the 2's cancel, leaving me with 1y. Over on this side, 2 goes into itself evenly and into 4 twice. And then I multiply straight across. And I get 2 times 3 is 6, 1 times 1 is 1, but I never leave 1 in the denominator, and I just get y equals 6. That's it. Okay? So let's do a check. Is 2/3 times 6 actually equal to 4? So again, to make this a little easier, I'll make it 6 over 1. 3 goes into itself once and into 6 twice. 2 times 2 is 4. And 1 times 1 is 1. 4 divided by 1 is 4. And that equals 4. So what that verifies is, yes, y has to equal 6. Now, for those of you who don't feel comfortable with that, let me show you an alternative. That's the fastest way, because in one step I solved the problem. Now, I can't remember who it was, but somebody said, well, you're multiplying and dividing at the same time with this. Was that you, Connor, or Kayla? Somebody back there I heard from. So we can use that idea. So what we could do is multiply both sides by the denominator. That's going to make that go away. And that gives me 2y equals 12. And then the opposite of multiplying by 2 would be dividing by 2. So if you feel more comfortable, you can do it in 2 steps. You're still going to get the same exact answer. Okay? Now, the reason why the first strategy is a little bit nicer is I have one more problem to show you. Everybody ready for that?
Yes.
All right, so this is my last example for you, and then you guys get to work on homework. That first strategy I shared with you, that if your coefficient in front of your variable is a fraction, the fastest way to get rid of it is to multiply by its reciprocal. It really comes in handy when what's on the other side is also a fraction, because then you've got your problem completely set up to solve in one step. So what would I multiply both sides by to get rid of negative 2/5 times the y? What would I multiply both sides by?
5 over negative 2.
Okay, and again, when we deal with negatives, always keep them up in the top. So
negative 5 over 2.
I'm going to make it negative 5 over 2.
Would be like 5, 2.
Okay, 5/2 is how you read that.
Oh.
So on the right side, we have these cancel, the signs. 2 negatives make a positive, so we get y equals. Over here, my signs are the same, so I'm going to get a positive, so I can put him in, and now I can start working on my problem. 2 goes into itself once and into 4 twice. 5 goes into itself once and into 15 3 times. I'm left with 2 times 1 is 2, and 3 times 1 is 3. So I'm going to go ahead and check this. And we had negative 2/5 times the y value of 2/3. Does that equal negative 4/15? So signs are different, so I'm going to get a negative. There's no canceling, so I'm going to multiply straight across. 2 times 2 is 4. 5 times 3 is 15. And sure enough, it worked out. So that verifies that, yes, y equals positive 2/3. Now, do you need to put the plus in front of it? No, you do not. Isabel.
For linear math.
Okay, I can never mind. Okay. Anybody else with a question?